Students, in this video, we will discuss nomenclature of alkynes, right? First of all, we must know what are alkynes. Alkynes are unsaturated hydrocarbons which contain triple bond between carbon atoms. So, alkynes, they are unsaturated hydrocarbons that contains triple bond between carbon atoms. Between carbon and carbon, there is a triple bond, right? Such compounds are known as alkynes. They are known as alkyne. An of E is replaced with ine. So that's why they are known as alkynes. Alk part shows the number of carbon atoms in the given organic molecule, right? And ine shows the presence of triple bond within the molecule. The general formula is formula for alkyne. General formula is CnH2n-2. Right, students? It means they contains 2 hydrogen less. They contain 2 hydrogen atom less. 2 hydrogen atoms less than corresponding alkanes. Alright, students. Now we will discuss the IUPAC rules for the nomenclature of alkynes. IUPAC rules for the nomenclature of alkynes. We will discuss these rules with the help of examples. Right, students? Let's see what is the first rule. The first rule is find the parent chain in the given organic molecule. Find the parent chain. What is a parent chain? It is the longest continuous chain of carbon atoms containing triple bond. Right, students? So parent chain is the longest continuous chain of carbon atoms containing triple bond. Right, students? So our first step is find the parent chain. Right? Let's see an example. How to locate the parent chain? For example, if we have a molecule like this, CH3, CH3, CH, C, triple bond, CH, CH2, CH3. Right, students? Suppose if this molecule is given. Now we will see how many chains are possible in this molecule, right? So find the longest continuous chain. 1, 2, 3, 4, 5. This is the chain which consists of how many carbon atoms? 5 carbon atoms, right? So we enclose this chain in the box. We enclose the chain in the box, right? Now another chain which is possible, we rewrite the structure. CH3, CH, CH3, CH, CH2, CH2, CH3, C triple bond, CH. Right, students? Now see another chain. 1, 2, 3, 4, 5, 6. Right? If we take this chain as a parent chain, now dear students, here you can notice how many carbon atoms are there in this chain. 1, 2, 3, 4, 5, 6. There are 6 carbon atoms in this chain, right? While in this chain we have 1, 2, 3, 4, 5. There are 5 carbon atoms. If we take this chain as a parent chain, right? It contains 5 carbon atoms. And if we take this chain as a parent chain, it contains 6 carbon atoms. But this is wrong. This chain is not correct. This is incorrect. What is the reason why this is incorrect? This is incorrect chain, incorrect parent chain. Why? Here you can notice this chain include just one carbon forming the triple bond, right? Okay, is this chain include both the carbon atoms forming the triple bond? They are not included in this chain. Both the carbons forming the triple bond, they are not included in this chain, although this chain consists of the largest number of carbon atoms, right? So it will not taken as parent chain. This chain is not correct. We will not take this chain as a parent chain, right, students? This is the correct chain. Why it is correct? Yes, since it includes both the carbon atoms forming the triple bond, right? So this is the correct parent chain. Okay, students. Now see the next rule. Next rule. Once we find the parent chain, then the next step is numbering the parent chain. Numbering of the parent chain. Numbering of parent chain. Students, how will do the numbering of parent chain, right? The parent chain is numbered in such a way that the triple bond which is present in the parent chain must assign the lowest possible number, right? It means we do the numbering in such a way that the triple bond will have the lowest possible number, right? Suppose in this molecule, if we do the numbering like this way, if we do the numbering like 1, 2, 3, 4, 5. If we do the numbering from left hand side, right? Here, what is the position of triple bond? Carbon number 4, triple bond. Triple bond is present between carbon number 4 and 5. So, what is the position of triple bond? It is present between carbon number 4 and 5, right? But if we do the numbering from our right hand side, 1, 2, 3, 4, 5. If we do the numbering from right hand side, what is the position of triple bond? Triple bond is present between carbon number 1 and carbon number 2, right? So we will write 1. Now compare these numbers, students. Which is the lower number? Of course, 1 is lower. 1 is lower, right, student? So this we will do the numbering from right hand side. This is a correct way of numbering. And this is not correct. We will not do the numbering from left hand side. We will do the numbering from right hand side to assign the lowest possible number to triple bond, right? When functional group and methyl radicals both are present within the molecule, right, we must prefer the functional group. We must assign the lowest possible number to functional group. Got it, students? Now, so we do the numbering of the parent chain in such a way that the functional group as well as the alkyl radicals, they must assign the lowest possible number. Clear, students? Now see the next rule. Now students, if we have more than one triple bond within the molecule, right, then how can we in the case of more than one triple bonds, if more than one triple bonds are present, then we will use the prefixes di, tri, etc. to specify the number of triple bond. So use the prefixes di, tri. We use prefixes di for 2 triple bond, tri for 3, tetra for 4 triple bond, and so on, right students? So to specify the number of triple bond in the alkane molecule, we use the terms di, tri, tetra, etc. Right students? For example, let's see an example. Suppose we have a molecule like this, CH triple bond C, C triple bond C, CH3. Now students, there are 2 triple bonds, right? Do the numbering of this molecule. If we do the numbering from right hand side, 1, 2, 3, 4, 5. If we do the numbering from right hand side, the first triple bond is present between carbon number 2 and carbon number 3. Dear students, obviously this is the parent chain, right? Once we find the parent chain, we must enclose the parent chain in the box here like this, and after that we do the numbering. If we do the numbering from right hand side, the first triple bond is present between carbon number 2 and carbon number 3, right? So here we write the position of first triple bond, and the second triple bond is present between carbon number 4 and carbon number 5. So what is the position of second triple bond? It is present between carbon number 4 and 5. Now if we do the numbering from left hand side, 1, 2, 3, 4, 5. Now if we do the numbering from left hand side, what is the position of first triple bond? Yes students, it is present between carbon number 1 and carbon number 2. 1, comma, first triple bond is present between carbon 1 and 2, so we write here 1. Second triple bond is present between carbon number 3 and carbon number 4, right? So what is the position of second triple bond? It is present between carbon 3 and 4. Now after that we will compare these numbers. Which are the lower numbers? 2 and 4 or 1 and 3? Of course 1 and 3, they are the lower numbers, right? So we will not do the numbering from right hand side. We will not do the numbering from right hand side, right? We will do the numbering from left hand side. Okay, now how many triple bonds are there students? There are 2 triple bonds, right? So we use, for the 2 triple bond, we use the term diene, right? Diene. How many carbon atoms are there? Since there are 5 carbon atoms, so it is pentadiene. Pentadiene. Diene shows there are two triple bonds, right? So before writing this name, we must mention the position of both the triple bonds, right? So let's try to write the name of this molecule. We know very well what is the position of first triple bond. It is present between carbon number 1 and 2. So we write 1, then place comma, and then write the position of second triple bond present between carbon number 3 and 4. So we write here 3 hyphen. How many carbon atoms are there? 5. In the alka part, we have 5 carbon atoms. So we use the term penta. 1, 3 penta. Since there are two triple bonds, we use the term di. Pentadiene. So, what is the name of this molecule? 1,3-pentadiene. I hope this is clear to you. Now, students, we see one more example in which we have more than one triple bond, as well as we also have alkyl radical. Then how can we assign the name to the given molecule? Suppose we have a molecule like this, CH3, C, triple bond C, CH, CH3, C, triple bond CH. Dear students, obviously this straight chain is the parent chain, right? This is the parent chain. So enclose the parent chain in the box like this. Everything which is outside the chain is a radical. Here we have one radical which is attached with the chain. Now after that, locating the parent chain, we do the numbering of the parent chain. Do the numbering. 1, 2, 3, 4, 5, 6. Here you can notice the first triple bond is present between carbon number 2 and carbon number 3, right students? And the second triple bond is present between carbon number 5 and carbon number 6, right? If we do the numbering from left hand side, these are the position of triple bond. That is, first triple bond is present between carbon 2 and 3, and the second triple bond is present between carbon number 5 and carbon number 6, right students? Now do the numbering from right hand side. 1, 2, 3, 4, 5, 6. If we do the numbering from right hand side, the first triple bond is present between carbon number 1 and carbon number 2, right? And the second triple bond is present between carbon number 4 and carbon number 5. So we write the position of second triple bond. After that, we will compare these numbers, which are lower number. Yes, 1 and 4, they are lower as compared to 2 and 6, right? So we will not do the numbering from left hand side. We will prefer to do the numbering from right hand side. Now coming to assign the name to this molecule. Here students, two triple bonds are present, so that's why it is diene. Diene, right students? How many carbon atoms are there? 6. So it is hexadiene. What are the position of triple bonds? 1, 4. 1, 4 hexadiene. Since there is a radical which is present in this molecule, identify the radical. This is, which radical is there? It is methyl radical, right students? Methyl radical. Now what is the position of methyl radical? Methyl radical is attached with carbon number 4. Now write the IUPAC name to this molecule by applying the rule. First of all, we write the position of alkyl radical 4 hyphen, name the radical methyl, 4 methyl, right? Again we place the hyphen, then we mention the position of both the triple bonds, right? First triple bond is, what is the position of first triple bond? 1, comma, what is the position of second triple bond? 4, right? Number and numbers, they are separated with the help of commas. Then we place hyphen. And how many carbon atoms are there? Total carbon atoms are 6, so we write hexa. Two triple bonds, di-ine, right? So number and letter must be separated with the help of hyphen. Numbers and numbers must be separated with the help of commas. Right, student? So what is the IUPAC name of this molecule? 4-methyl 1,4-hexadiene. I hope this is clear to you, students. Now, students, we will see some other examples of nomenclature. We see some more examples. Now, if we have a molecule like CH3, CH, CH3, CH, CH3, C, triple bond, CH. Right, students? Now, apply the rules for the nomenclature, IUPAC rules for the nomenclature. First of all, we find the parent chain in this molecule. Obviously, this is straight chain. It contains 1, 2, 3, 4, 5 carbon atoms. So that's why this is the parent chain. This is straight chain. It is the parent chain of the molecule. Once we find the parent chain, right, everything which is present outside the chains, they are alkyl radicals. So how many alkyl radicals are attached with this chain? We have 2 alkyl radicals which are attached with this chain. Right, students? So do the numbering of this chain. Do the numbering. One, 2, 3, 4, 5. If we do the numbering from right hand side, what is the position of triple bond? Carbon 1 form the triple bond. Right, students? And if we do the numbering from left side, 1, 2, 3, 4, 5. Carbon number 4 form the triple bond. Obviously 1 is lower as compared to 4, so we will not do the numbering from left hand side. We do the numbering from right hand side. Right, students? Now assign the IUPAC name to this molecule. In this molecule, you can notice we have alkyl radicals. Identify the radicals. This is methyl radical, right? As well as this is also methyl radical. So how many methyl radicals are there? In this molecule we have 2 methyl radicals, right? So we use the term dimethyl to show there are 2 methyl radicals. Now assign the IUPAC name to this molecule. First of all, we write the positions of both the methyl radicals. The first methyl radical is attached with carbon number 2, right? We do the numbering from right hand side. So the first methyl radical is attached with carbon number 3 and the second methyl radical is attached with carbon number 4, right? So here we write 3, 4 hyphen dimethyl, right? And what is the position of triple bond? It is present between carbon number 1 and 2, so it is 1. And how many total carbon atoms are there? 5. So 1 pentyne. I hope this is clear to you, students. Now let's see one more example. Suppose we have a molecule like CH3, CH3, CH, CH2, CH3, C, triple bond, C, CH3. Now apply the IUPAC rule for the nomenclature to assign the name to this molecule. First of all, we find the parent chain. Now this is the straight chain which contains 1, 2, 3, 4, 5, 6 carbon atoms, right? Or 1, 2, 3, 4, 5, 6 carbon atoms, right? So 1, 2, 3, 4, 5. We will not take this chain as a parent chain, right? Since it do not include both the carbons forming the triple bond. Right, students? So, if we take the straight chain as a parent chain, you can take the straight chain as a parent chain like this. This is the parent chain, right? Once we find the parent chain, our next step is numbering the chain. Do the numbering from right side. 1, 2, 3, 4, 5, 6. Right? If we do the numbering from right hand side, what is the position of triple bond? It is present between carbon number 2 and carbon number 3. Now students, do the numbering from left hand side. 1, 2, 3, 4, 5, 6. What is the position of triple bond? It is present between carbon number 4 and carbon number 5. So, position of triple bond is carbon number 4. Now, compare these number. Which is a lower number? Yes, 2 is lower. So, we will do the numbering from right hand side. Right? We will not do the numbering from left side. Since 2 is the lower number. Now students, you can notice here there are two radicals. Two radicals are present here, right? Here we have the radical, here another radical is there. The radical which is made up of single carbon atom is methyl radical, right? And this radical which is made up of two carbon atom, it is ethyl radical. Now in case if we have different types of radicals, right? Then which should be written first? What should we do? Yes, students, we must follow the alphabetical order, right? E for ethyl and M for methyl. So, first of all, we will write ethyl radical. Whatever is the position of ethyl radical on the parent chain, first of all, we mention the ethyl radical. So, write the IUPAC name to this molecule. What is the position of ethyl radical here, students? Ethyl radical is attached with carbon number 4, so we write 4-ethyl. 4-ethyl, again we place hyphen. What is the position of methyl radical? Methyl radical is attached with carbon number 5. 5-methyl, 5-methyl, and what is the position? Again we place hyphen. What is the position of triple bond? It is present between carbon 2 and 3, so we write 2. And how many total number of carbon atoms are there? 6, right? So, hexyne. Hexyne. So, what is the IUPAC name of this molecule? 4-ethyl, 5-methyl, 2-hexyne. I hope this is clear to you, students. Now, students, we see some compounds which contains double and triple bonds at the same time within the same molecule, right? So let's see some compounds which contains double and triple bond within the same molecule. So how to learn naming of compounds? Naming of compounds containing both the double and the triple bonds. Containing both the double and triple bond. Double and triple bonds, right? It means if both the bonds are present, both types of bond, double bond as well as triple bond, if both the types of bond are present within the organic molecule, then how can we assign name to those organic molecules? When double and triple bond both are present in the organic molecule, right, at the equal positions, I will explain this rule with the help of some examples, right? First of all, if we have a molecule like this, CH2, double bond C, CH, CH2, C, triple bond CH. Here students, you can notice this is the molecule which contains both double as well as triple bond, right? Now obviously this is the parent chain of the molecule, right students? Now when we find the parent chain, in the next step we will do the numbering of the parent chain. Okay students, now start the numbering. If we do the numbering from left side, 1 2 3 4 5, right? And do the numbering from right hand side, 1 2 3 4 5. Now in this molecule students, if we do the numbering from left side, carbon number 1 form double bond with carbon number 2, right? So what is the position of double bond here? Double bond is present between carbon number 1 and 2. So position of double bond is carbon 1. And what is the position of triple bond? Triple bond is present between carbon number 4 and carbon number 5. So position of triple bond is carbon number 4. Right students? Now if we do the numbering from right hand side, right, what is the position of triple bond? Triple bond is present between carbon number 1 and carbon number 2. Here you can notice triple bond is present between carbon number 1 and carbon number 2. So what is the position of triple bond here? Triple bond is present between carbon 1 and carbon number 2. And double bond is present between carbon number 4 and carbon number 5. So the position of double bond is carbon number 4. Here you can notice the students, if we do the numbering from right side, right, carbon 1 form the triple bond while carbon number 4 form the double bond. And if we do the numbering from left side, carbon number 1 form the double bond while carbon number 4 form the triple bond. ठीक है बेटा, लेकिन जब हम इसका नाम लिखते हैं ना, always we will prefer double bond. It means if double and triple bonds they are present at the same positions. ठीक है ना, यहाँ पे देखें कार्बन नंबर 1 form double bond, here carbon number 1 form double bond, right? If both the double and triple bond they are present at the same positions, right, then we will do the numbering from that end from where the double bond is present, close to the terminal carbon, right? Or we assign the lowest, यानी हम उस तरफ से नंबरिंग करेंगे जहाँ से डबल बॉन्ड टर्मिनल कार्बन के करीब है. ठीक है? So the name of this molecule will be, there are two ways to write the IUPAC name to this molecule, right? Simply if you hide the triple bond, then how many carbon atoms are there? 5, right? And what is the position of double bond? Simply you can write its name like it is 1, 5 carbon atoms are there, so you will write 1 pentene, right? And what is the position of triple bond? Yes, carbon number 4 and carbon number 5. So we place hyphen 4 comma 1 pentene 4-ine. We place hyphen here. 1 pentene 4-ine. Okay students. Or the second way by which we can assign the name to this organic molecule. The second way is, first of all, you will write the alk part. That means the number of carbon atoms, right? How many carbon atoms are there? 5. So simply you will write, we use the term pent for 5, right? Pent, what is the position of double bond? Yes, carbon 1. So you can write pent 1n, right? And carbon number 4 form the triple bond with carbon number 5. So we will write 4-ine, right? This is the second way. Pent 1n 4-ine. You can write this name, or you can write 4-pentene 1-pentene 4-ine, right students? I hope this is clear to you. Now let's see another example, one more example. Suppose we have a molecule like CH3, CH double bond CH, CH2, C triple bond C, CH3. Right, friends? Obviously, this is the parent chain. Enclose the parent chain in the box like this. Now, do the numbering of the parent chain. 1, 2, 3, 4, 5, 6, 7. What is the position of triple bond? It is present between carbon 2 and 3. And what is the position of double bond? Between carbon 5 and carbon 6. Right? This is the position of triple bond and this is the position of double bond. Right? Now do the numbering from left hand side. 1, 2, 3, 4, 5, 6, 7. What is the position of double bond? Double bond is present between carbon number 2 and carbon number 3. This is the position of double bond. And triple bond is present between carbon number 5 and carbon 6. So the position of triple bond is carbon number 5 and 6. Now here we will assign the lower number to double bond. Right, students? Lower number to double bond. Since the position of both the triple bond as well as the double bond are same. So we will do the numbering from that side from where the double bond is close to the terminal carbon. हम उस तरफ से नंबरिंग करेंगे जहाँ से डबल बॉन्ड टर्मिनल कार्बन के करीब है, ठीक है, ताकि हम डबल बॉन्ड को लोवेस्ट नंबर असाइन कर सकें. ठीक है. So we can write the name of this molecule by two ways. Right? Hide the if we hide the triple bond, total carbon atoms are 7, right? And the position of double bond is carbon number 2 from the double bond, right? So the name of this molecule will be 2-heptene. 2-heptene, right? Again you place the hyphen and write the position of triple bond 5-ine. So the IUPAC name of this molecule is 2-heptene 5-ine. You can write the name like this, right? Or another way to assign IUPAC name to this molecule. First of all, you write the alk part. Since there are 7 carbon atoms, so you can write hept. Hept shows there are 7 carbon atoms. Place the hyphen hept. Now, what is the position of double bond? 2. So you can write 2n. Hept 2n. Place the hyphen and write the position of triple bond 5 and then hyphen and you will write ine. So hept 2n 5-ine. This is another way to assign to write the IUPAC name of this molecule. I hope this is clear, students. Now students, see one more example. If double and triple bond both are present simultaneously within a molecule, right, then how can we assign IUPAC name to the molecule? Let's see one example. If we have a molecule like CH triple bond C, CH double bond CH, CH3. This is the molecule which is given to assign IUPAC name. Now, what is the rule? If triple bond is close to the terminal carbon, then it must be preferred for numbering. Apply the rule to this molecule. Now, if we do the numbering from left side here, 1, 2, 3, 4, 5. When we do the numbering from left hand side, carbon number 1 form triple bond, while carbon number 3 it form double bond. Similarly, if we do the numbering from right hand side, 1, 2, 3, 4, 5. From right hand side, carbon number 2, it form the double bond, while carbon number 4 form the triple bond. Now in this case, students, since triple bond is close to the terminal carbon, so it must be preferred for numbering. So this is the correct way of numbering. Now assign the IUPAC name to this molecule. The IUPAC name of this molecule is, it is, how many carbon atoms are there? There are 5 carbon atoms, right? So in alk part we have 5 carbon atoms. And what is the position of double bond? Yes, carbon number 3 form double bond with carbon number 4. So we must write the position of double bond first. That is 3, and it is pentene. There are 2 ways by which we can assign the name to this molecule. 3-pentene. And what is the position of triple bond? Carbon number 1 form the triple bond, so 1 ine. ठीक है. Whatever is the position of double bond in the molecule, first of all we will write the double bond, right, and then we will write the triple bond. ठीक है ना. पहले हम डबल बॉन्ड को लिखेंगे और उसके बाद हम ट्रिपल बॉन्ड को लिखेंगे. और another way by which we can assign the name IUPAC name to this molecule is, in the alk part we have 5 carbon atoms, so we will write pent, right. Then what is the position of double bond? Since carbon number 3 form double bond, so we write 3-N. And what is the position of triple bond? Carbon number 1 form triple bond, so 1 ine. Pent 3N 1 ine. Now let's see one more example to understand the concept more clearly. If we have this molecule like CH3, C, triple bond, C, CH, double bond, CH, CH2, CH3. Now assign the IUPAC name to this molecule. Here you can notice 1, 2. If we do the numbering from left hand side, second carbon form the triple bond. 1, 2, 3, 4, and fourth carbon form the double bond. That is 1, 2, 3, 4, 5, 6, 7. Triple bond is present between carbon number 2 and carbon number 3, while double bond is present between carbon number 4 and carbon number 5, right. Now do the numbering from right hand side. 1, 2, 3, 4, 5, 6, 7. Here you can notice, students, double bond is present between carbon number 3 and carbon number 4, while triple bond is present between carbon number 5 and carbon number 6. So which is the lower number? 2 is lower than 3. Since triple bond is formed by carbon number 2 and double carbon number 2 and carbon number 3. If we do the numbering from left side, यानी अगर हम लेफ्ट साइड से नंबरिंग करेंगे तो ट्रिपल बॉन्ड जो है वो कार्बन नंबर 2 और कार्बन नंबर 3 के दरमियान है. ठीक है. अगर हम राइट साइड से नंबरिंग करेंगे तो डबल बॉन्ड कार्बन नंबर 3 और कार्बन नंबर 4 के दरमियान मौजूद है. सो विच इज़ द लोअर नंबर, 2 और 3? Obviously 2 is the lower number. ठीक है. So this is the correct way of numbering. Now assign the IUPAC name to this molecule. Whatever is the position of double bond in the molecule, first of all we will write the position of double bond, right, and then we will write the position of triple bond. So double bond is present between carbon number 4 and 5, so IUPAC name of this molecule is 4. And how many total carbon atoms are there? 7. So 4 hept. Hept means 7. 4 heptene. 4 heptene. And what is the position of triple bond? It is present between carbon number 2 and 3. So we write 2-ine. The IUPAC name of this molecule is 4-heptene 2-ine. Now the second way by which we can assign IUPAC name to this molecule, it is First of all, we write the alk part of the molecule. In the alk part, we have 7 carbon atoms, so it is hept. Hept means 7. The position of double bond is 4. Hept 4N hyphen, and triple bond is present between carbon number 2 and 3, so we write 2-ine. Hept 4N 2-ine. I hope you got the concept. Now here some names are given to us, right? In the next question, some names are given to us and we are asked to draw the correct structures. Draw the structures. To the following names. Organic molecules, organic compounds. Let's see what compounds are given to us, then we will draw their structures. The first one is 1-hexene 3-ine. The first structure which is given is 1-hexene 3-ine. We will note the number of carbon atoms in the parent chain. Hex shows total carbon atoms are 6. So we made the skeleton of 6 carbon atoms. 1, 2, 3, 4, 5, 6. Do the numbering either from right side or from left side. 1, 2, 3, 4, 5, 6. 1 shows there is a double bond, one hexene. 1 shows there is a double bond between carbon number 1 and carbon number 2. So we make a double bond between carbon 1 and carbon 2. 3-ine. 3 shows there is a triple bond between carbon number 3 and obviously between carbon number 4. So here we make a triple bond between carbon 3 and 4. We make a triple bond. Now fill the vacant vacancies with the help of hydrogen. 1, 2 plus we add 2 hydrogen. 1, 2, 3, 1 hydrogen. 1, 2, 3, 4. This carbon is tetravalent. 1, 2, 3, 4. And this carbon is also tetravalent. 1, 2 plus we add 2 hydrogen. 1 plus we add 3 hydrogen. Right? So this is the correct structure of 1-hexene 3-ine. Let's see one more example. Another example. 1,3-pentadiene. 1,3-pentadiene. Now draw the correct structure of this organic compound. Penta shows total carbon atoms are 5. So we make a skeleton having 5 carbon atoms. 1, 2, 3, 4, 5. Now do the numbering either from right side or from left hand side. 1, 2, 3, 4, 5. Now diene shows there are 2 triple bond in the molecule. Diene means there are 2 triple bonds. What are their positions? 1, 3. 1 shows the first triple bond is present between carbon number 1 and carbon number 2. So here we make the first triple bond between carbon 1 and 2. 3 shows the second triple bond is present between carbon number 3 and carbon number 4. So here we make the second triple bond. Now fill the vacant vacancies with the help of hydrogen. 1, 2, 3 plus 1 hydrogen here to make this carbon tetravalent. 1, 2, 3 and 4. This carbon is tetravalent. Now see this carbon 1, 2, 3, 4. This carbon is tetravalent. 1, 2, 3 and 4. This is tetravalent. 1 plus we add 3 hydrogen over here. So this is the correct structure of 1,3-pentadiene. I hope you got the concept, student.